What if the universe's ultimate speed limit isn't just some random number that happens to be what it is? Today, we're going to dive into a pretty radical new idea that suggests the speed of light isn't a rule that was slapped on reality, but something that grows directly out of its most fundamental architecture.
We all know the rule, right? You probably learned it in school. There's an absolute, unbreakable speed limit in our universe, the speed of light, which we call c. It's like the ultimate cosmic stop sign. Nothing with mass can ever reach it, and even light itself can't break it. It's a pillar of modern physics. But have you ever really stopped to ask why? I mean, why that specific speed, around 300,000 kilometers per second? Is it just an arbitrary setting for the universe? Or could that number be whispering something incredibly profound about the very fabric of space-time itself? Well, to even begin to find an answer, this new theory says we have to completely throw out our old picture of space-time. It argues that the smooth, continuous sheet we imagine reality to be is just an illusion. The real answer, it says, is hiding in the pixels underneath it all. So on the left, you've got the old view, this smooth, continuous fabric that you could, in theory, zoom into forever and ever. But the new view, over on the right, it's a whole different ballgame. It suggests space-time is discrete, that it's built from these fundamental indivisible units, kind of like pixels on a screen. There's a point where you just can't zoom in any further. Okay, so the first building block in this new model is something called the junctional sphere, or JS for short. You can just think of it as a single, indivisible pixel of reality. And here's the mind-bending part. These things aren't objects in space. The network they form literally is space. Now, naturally, when you pack a bunch of spheres together, you're going to get little gaps in between them. In this model, these are called structural holes, or SH. But an SH isn't just empty space in the way we usually think of it. It's a region that is specifically defined by the total absence of the connections that create space in the first place. And this picture here shows the most important rule of this whole pixelated universe. Light isn't some little particle zipping through empty space anymore. No. Here, it's a signal that can only travel along the connected boundaries where these JS units touch. See how the path has to hop from one boundary to the next? It is physically forbidden from taking a shortcut across that void. So let's just lock in those rules real quick. A signal, like light, can only travel on the network of JS boundaries. It is totally confined to this grid. And critically, it absolutely cannot cut across the voids. This idea of confinement is the key to everything that comes next. Okay, so now that we have our cosmic building blocks, the JS pixels and the SH voids, we can finally see how this underlying architecture actually builds speed of light from the ground up. Think about it. If space-time is made of pixels, then there has to be a smallest possible step you can take. In space, we'll call it L step. And this isn't some random length, it's a distance that's baked into the very geometry of hopping from one JS boundary to the next. It's the universe's fundamental unit of distance. And you guessed it, just as there's a smallest possible distance, there has to be a smallest possible unit of time. T step. This is the fundamental tick of the cosmic clock, the absolute minimum time it takes for the network to process one of those little spatial hops, to pass a signal from one pixel to its neighbor. As the source paper puts it so well, a discrete spacetime admits only discrete admissible propagation lengths and discrete admissible propagation times. In other words, if you have a smallest possible chunk of distance and a smallest possible tick of time, well then a maximum speed becomes totally inevitable, doesn't it? And here it is. This is the big reveal. The speed of light, c, is no longer some mysterious, magical number. In this model, it is simply the ratio of the smallest possible step in space, L step, divided by the smallest possible tick of time, t step. It's speed defined in the most basic way you can imagine. One fundamental unit of distance per one fundamental unit of time. So this is the takeaway. The speed of light isn't a magic number that was just plucked out of thin air. In this view, it's more like the fundamental gear ratio of the universe's engine. It's a property that emerges directly from the structure of the machine itself. So, if this is actually true, what does it really change? Well, it's a lot more than just a new way to calculate c. It fundamentally redefines what c is, and it redefines what the universe itself is made of. So what are the huge consequences? Well, for starters, c stops being a fundamental constant that we just have to accept on faith. It becomes a structural invariant, a property that emerges from the structure of reality. Second, the reason c is the same everywhere you look is because the underlying pixel grid of the universe is the same everywhere. And finally, Yeah. It means our entire perception of a smooth, continuous reality is basically a low-resolution illusion.
Now, you might be thinking, hold on, isn't this just a bit of circular reasoning? That's a great question, and the paper is very careful to lay out the logic. It's a one-way street. Step 1, you define the geometry of this JSS shapes network. Step 2, from that geometry alone, you derive the minimum possible length and time. It's only then, in step 3, that you calculate their ratio to get a maximum structural speed. The final step is to compare that number you just calculated to the speed of light we actually measure in the real world. No circularity at all. This table really just hammers home what a massive shift in thinking this is. The conventional view sees spacetime as this continuous, passive background, and the speed of light is just a rule we assume to be true. But in this new framework, spacetime is a discrete, active structure, and C is an inevitable, geometric consequence. We go from simply assuming something to actually deriving it. All of this leads to a final, and honestly pretty mind-bending way of seeing the universe. If this model holds up, reality isn't a static stage where things happen, it's an active, ongoing process. There's a quote from the source material that just captures this perfectly. The universe is not a continuous passive arena, but a microscopic geometric engine that processes information through discrete structural updates. What we experience as time and motion is just that engine running, processing reality one pixel, one structural update at a time. And that brings us right back to the beginning. Light is no longer this mysterious thing. In this view, it's simply the fastest stable signal that the universe's engine is capable of processing. It's the processor speed of reality itself, baked in from the very beginning. So, this leaves us with one final, pretty provocative thought. If the smooth, seamless continuity of spacetime is really an illusion, what else is? What other fundamental parts of our reality, things we take for granted every single day, are just high-resolution illusions that emerge from a hidden, pixelated world underneath it all?